Hi, welcome to Module 5 of From Zero to Bot. So in this module, I'm going to be teaching you how to create a basics trading strategy. And this will be an expansion of Module 4, where we learn how to do limit orders. So we're going to expand on that. We're going to actually build a trading strategy. And I'm going to show you how to do it using the framework that I built. So let's get into it. So I got a chart here. I'm not endorsing this token or anything like that. This is just something that popped up, and I'm going to use it as an example here. So what I'm trying to implement here is a buy the dip strategy. So note, this is going to be a very, very basic strategy, but this is just to show you how to build your own trading strategy using the framework I'm providing. So I'm not endorsing this strategy or anything like that. It's just a very simple basic strategy to get your feet wet and free to get going and start creating and brainstorming your own trading strategies. So with that, so we got this token that's on an uptrend, right? So we got higher lows going on here. It looks pretty positive. So if we are at a peak here, we don't really want to buy on the top. What we want to do is wait for a pullback, and we want to buy on the dip on this just to maximize our profit, right? So this could amount to quite a bit. So if we get our ruler out or info line, like if we just from here to here is a drop of 1.49%. So this is a 1 second candle. So that's from 1 second to the next, right? There's a drop in 1.49%. That's probably due to the fact that this is a very low market cap coin. So we can maximize our profits by buying on the dip on this sort of trade. So that's the idea right here. We're going to go ahead and build a mechanism to gather historical data. We're going to create candlesticks basically in our software. And what we're going to do is we're going to compare our current candle, where we're at, our current price basically. We're going to check it with the previous candle's low. So previous candle's low here was at the bottom here, and what we want to do is we want to go in and buy the dip on that. So we want to make sure that we drop a certain percentage before we actually commit to buying this token. So if we don't meet those conditions, we won't buy it. If we do reach a dip in price that meets our requirements, then we'll go in and buy it. So not only are we going to buy it, we're also going to set a limit order when we buy it. So we're going to try to get a certain amount of profit. We're also going to set up a stop loss, an 80% stop loss, so that we don't lose our lunch on the trade if it goes south. So you all know by now that I like pictures, so let's get into the design of this whole thing. All right, so how are we going to build this thing? It's easy. Don't worry about it. So I got you. First thing we're going to do is we're going to start off with a main, right? So we're going to have a main class that kind of kicks off everything. Our main is actually going to read from a config file. We're going to call this our strategies.json. This is going to contain all the data that we need to implement our strategy. Okay, so what do we need in our strategy? Well, obviously we need a dip price, or not dip price, but dip percent that we're looking for between candles. So for now, I'm just going to keep it to 2%. The other thing we need is chart interval. So that's just the candlestick length in time. And we're going to set that to 60. We're going to use 1 minute candles for this. So they're in increments of seconds. So that's the highest resolution you got for a chart. I don't think they go lower than 1 second. And we can have other information in here like priority fees, the token address. Obviously, if we want this to be automated, we'll go ahead and set up a token address. And you'll see this in premium bots where they let you set some of this stuff up. I don't think there's any premium bot that allows you to do custom strategies like this, but let me know if you know of one. That'll be interesting to know. I know this isn't easy information to find, so I'm just trying to fill the gap for that because I do see the need. Other information is you can add limit orders to this thing. So let's say, remember I said that I want to start a limit order. We have that info in there, so we can put the trigger percentage, once we buy, when do we want to sell, stop loss order info, and that's about it. There's other things that we can put in there, and we'll get into it as we get in the code, but that's the idea. This has information we can use to deploy our strategy. So once we kickstart that, main is going to talk to TradesManager. We all know what TradesManager is. It's got a pretty defined responsibility. Its job is mainly to execute trades and manage them. So main is going to talk to that, and it's going to pass over a strategy order to execute. Trades Manager is going to do its thing. It's going to figure out what type of strategy to create, and it's going to execute it and maintain it. So it's going to put it in its own records so it can maintain what the active trades are. It does maintain active trades records. And this strategy right here is the bread and butter. And what it's also going to do is going to employ the help of signal generators. So strategies can be very complex. You can have a number of signal generators. So that's why this little diamond here means that this strategy could be composed of a bunch of signal generators, one to many, zero to many, actually. So we're going to use one signal generator in this strategy, the buy the dip, and it's just going to be called buy the dip signal generator, basically. And strategy will go ahead and instantiate that and use it to check to see if the dip has been reached. So in addition to this, we'll also need the help of the market manager. So that this market manager will be hanging out. It's got a sole responsibility of managing market conditions, or keeping the state of things, keeping the state of the tokens that we're monitoring, right? That's basically it. So our strategy or signal generators may be utilizing querying market manager for data like candlesticks. Remember we were talking about candlesticks? We're going to use candlesticks here. So we're going to have to make a mod to the market manager to maintain candlesticks for tokens that we're interested in. This is just a high level overview. You'll see this in action when we start coding, but that's the idea. So this is the bread and butter, our signal generators. I kind of include these as a package. We're going to need strategy with accompanied signal generators to get this working. This is going to be the majority of the work. Trades Manager will need a little bit of a tweak. We'll have to update the Trades Manager with the ability to instantiate the strategy. And there's going to be a tweak in Market Manager to maintain candlestick records. And we're going to have to create a candlesticks class to help us out. In addition to that, there's probably going to be some mods. We have TradingDTOs, data transfer objects. We have a file just for that. It's the TradingDTOs.py. So there'll probably be some additions, some new data structures that I put in there, some new enumerations, things like that to help us on our course. So that is the basic framework for this. And in the future, I'm building a new framework called TX-DeFi, Transmission DeFi. And it's going to have the same architecture, and it's going to be very, very easy to build to. So what you're doing right now, you're learning how to use this framework and learning how to adapt to it so that you can build your own trading software, basically, without the hassle of, without having to put in the work and create this framework yourself. So look for that in the future. My plan is to get that out by February, and I will be putting another video together that shows the benefits of using this framework. So calling it TX-DeFi. TX is short for transmission in the technical sense. But look for that February, and there'll be some announcements coming through on this very soon. And the features list is on the website, so you can go to crypto meta gm.xyz or .com if you want to. Also got that. So you go there, and if you go to the NFT perks section, you can see what the list of features are for TX-DeFi. It's not an all exhaustive list. There's a lot in there. It's basically your framework for building your own bot, but it'll be a pretty powerful system to build on. And it already contains a lot of features that a lot of these premium bots that cost thousands of dollars. It has features that those bots have already. So it already has a lot of powerful capability. In addition, it'll be a great system to build on. Anyway, I just want to give you my little elevator pitch on that. TX-DeFi, it's coming. So let's get on to our lesson here. All right, so we're going to start off where we last left off on module 4. So let's go ahead and create a new main class. We'll call it strategy main. The reason why I'm doing this is I don't want to mess with the main we created already. So for module 4, so we're just going to create a new main to test out our strategy. I'm going to copy a bunch of stuff that we had in our main. So let me just do that right now. All right, so what I'm copying over is some of the defaults we had in there for default buy amount, slippage, priority fee. Also our loading of our EMV variables for our RPC node and our keys. And you guys are familiar with it. We need the RPC API, we need the market manager, we need the trades manager. Okay, the other thing I'm going to copy over is we need a way to run this thing. And I'm copying over the async run main, putting that at the end here. All right, so this is the part where we're gonna actually create something new here. So what I'm gonna do is I'm gonna open up the config file. We haven't created this yet, but we'll get into that. I'm gonna open up the config file and I'm gonna put it inside a folder called config, and I'm gonna call this strategies.json. And you only need to read this thing, so I'm gonna put in this parameter R, that means read only, and we're gonna read this as a file. Okay, let's type that in exactly as is. And what we're going to do is load this strategies file into JSON. Basically, this line right here is going to convert this over to a dictionary that we can parse very easily in our code. So we're going to load that file. Once we load it, we're going to check to see if it actually was JSON, valid JSON. If it was, then we'll have strategies filled out for us. It should be a dictionary. There could be multiple strategies in here, so we'll go ahead and account for that. I'll go ahead and create a for loop called strategy or strategy settings in strategies. Okay, what I want to do is I want to get the token address for the strategy. So you'll see this in a lot of premium bots. They'll have this pre-set up stuff, and you have to define what token address to subscribe to for your strategy, particular strategy, whether it be a limit order or some sophisticated strategy. I haven't run into any premium bots that have this ability to run anything beyond like limit order. So I think this is something that you won't find anywhere else in a premium bot. Let me know if I'm wrong about that, but as far as some of the premium bots that I've come across, there hasn't been any advanced strategy features in those bots. Typically, if you want some sort of custom type of strategy implemented, you'd have to do it yourself or hire somebody to do it. So that's what I'm teaching you right now. So part of the reason I'm doing this is to fill that gap. I know that there's a lot of people that want this, so that is why I'm here. So all right, so back to this. So our strategy settings, we're gonna get some info from our strategy settings, and what I'm gonna do is I'm gonna pull out the token address, and I'm gonna add in a default here, NA. If it doesn't exist, maybe it's just a strategy that can be applied dynamically. So that'll be in the future development stage where we actually have a GUI for this thing where will allow the user to actually apply a strategy to a selected token of choice. But for now, we'll just pull that information from the strategy settings. And if it's there, it's there. If not, we'll just initialize that to NA. We're also going to get the module file name. So this would be the actual implementation for the strategy, and we're going to get into that. So I explained that a little bit in the design. Hopefully that made sense, but this will become more clear as we complete our implementation for our strategy. So we're going to get our strategy settings for the module file name, and we're going to do NA again if it's not there. So I would say that if you get NA, then that's probably not a valid strategy. We need to be able to load the strategy. So we're going to go ahead and next, we're going to check if our token address is valid, basically not equal to NA, and our module file name is equal to something that we have available. So what I'm going to do is I'm going to create this thing called simple by dip engine.py. And by the way, this is typically not good practice to have these strings in here, these literal string comparisons. You want to typically put these into constant variables like in a global file or something like that. But since I'm trying to do this very quickly, I'm just doing it this way. But just FYI. All right, so if that falls into place, we're going to create this file, by the way. So this would need to exist, a simple by dip engine. So we're going to create an order, strategy order. So I did explain that in the design. So strategy order equals strategy order. This is just going to be a variant of the strategy of the order class that we created. So we'll do that in a second. We'll go ahead and implement that. So what we're going to do is we're going to give it an order type, and we're going to give it an order type of simple by dip strategy. We're going to pass in the token address. We're going to pass in the default buy amount. We're going to pass in default slippage. We're going to pass in the default priority fee. And then the last thing that is unique is we're going to pass in the strategy settings. And this would be just the dictionary that we just loaded from the JSON. And the last thing we need to do is we need to go ahead and we need to execute the order. So this is an asynchronous call. So we're going to do an await on the trades manager. We're going to go ahead and call execute order. This isn't any different from what we did last time. So we're going to execute the strategy order. We're done with our main. So we had all these implemented. We could actually run this, but we don't. We don't have everything implemented. So let's get into the JSON file, the strategies file. So let's go ahead and create something. So by the way, this project is getting larger. It's starting to scale up. In the final bot code, in the advanced material, I will be organizing this much better. Things will be organized in folders and things like that. But just want to let you know that things will be much more organized in the final material, and things will be refactored as well to optimize maintainability and performance as well. All right, so let's create a new file called strategies. Actually, let's create a new folder, not a new file. We're gonna go and create a new folder called config. We're gonna put our strategies JSON in there. New file, strategies.json, whatever you want to call it. I've never gotten a clear idea of what it's supposed to be. I think it's supposed to be JSON. Tomatoes. All right, so let me go ahead and just copy what I have here for my JSON, and I'll just explain to you what the contents are. So this is the start of my JSON. This is basically saying that these open brackets, this opening brace here indicates that this is an array. So in the future, I will have multiple strategies. I will want to be able to execute multiple strategies on several different tokens. I may want to load in a strategy so that the user can dynamically execute a strategy on a particular token of their choice. So in here we have name value pairs. We're limited to name value pairs basically in a JSON. You can't have advanced objects or anything like that. Your code can interpret this and convert these to more complex objects, and we'll do that, but JSON is limited to just name value, simple name value pairs. You can have strings. The values could be strings, they could be values, and that is the current limitation of JSON. So everything in here has to be represented with text basically. And I think you know that from past modules, so I think we covered a little bit of that. So the first thing here is the file name, the simple by dip engine. This just indicates what engine we are going to use in this strategy. Strategy title, not really too important. It's just the title of the strategy. We're gonna create buy the dip on a 1 minute chart, and the token address, you put in the token address that you're interested in. Trigger drop percent, so we're buying on the dip, so the trigger drop percentage indicates when we actually execute the order for this strategy. So we're buying on the dip, so if it drops more than 2% from the last candle, then we'll go ahead and purchase a certain amount of this token. The chart interval indicates the candlestick length. So by setting this, would be in seconds. So by setting this to 60, we're indicating that we want 1 minute candles to perform this strategy on. The amount in, that's the SOL amount that we want to buy in to this token. You could also easily replace this with a percentage of your portfolio value, or your SOL value. So it's whatever you want to do, but for now this is just a literal SOL value, 0.001. Slippage, priority fee, etc. You all know about that. So these would be optional. You could probably leave these out because the intention is to have some default values for these, and we already do in the main. But if you wanted to have specific slippage and priority fees for each strategy or token, then you could actually put them in here. So that's why I'm putting them in here. But like I said before, you can have general settings that apply to all tokens that don't have this information. So if this was deleted, it would just use the general settings. So we will set the software up to do that. I got a section here for limit orders. So I got information on limit orders. So we could potentially have more than one limit order here. But right now I just have one set. So this is saying that if the trigger percent is, well, if the price goes up 80% from the time we buy, then we're going to go ahead and execute a sell order. So that's what this limit order is. And the stop loss order, if the price goes below 80%, we're going to go ahead and sell all of our allocation that we bought. So these are optional, but I put them in here because they're part of our strategy. So that is done. So let's go back into the main. I think we're done with the main actually. So we got our strategies main here. The next thing we got to implement is we got to make a mod to our TradingDTOs class. This right here needs to go. That's not right. So let's go to TradingDTOs. So down here we got an order implemented. What we're going to do is we're going to implement something called the strategy order class that inherits from order. It's sort of similar to the order with limit stops, but this one's going to have an additional input for strategy settings. So that's it. It's pretty basic. It's just got a constructor that takes in an additional parameter called strategy settings. The other change we have to make here is also an enum. So right now we have the option to do buy, sell, limit order, or other. Let's go ahead and create another entry here for simple buy the dip strategy. So I'm going to change the indexes here. So there's that. Just added that. Remember to add in the comment or the commas after each entry. That's just the syntax of these things. The other thing is you want to make sure that these numbers are unique. These indexes are unique. Just FYI if you didn't know that. All right, so we're done with our change here. The next thing we got to do is make a change to our trades manager. So in executing the order, we don't need to modify this one. This is already pretty much set to go. What we need to do is we need to add in something else in our create strategy. So this is basically using a factory pattern basically. So given some inputs, we're going to create the engine that we need. So one change right here is this is for us basically. So there's no real typing in Python. So this is for our reference. So this indicates that we're going to return a P&L trading engine. Well, we're doing more than that now. So what I'm going to do is I'm going to create this class called an abstract trading engine. So every trading engine will have to inherit from abstract trading strategy, and that does not exist yet, but it will. So even P&L trading engine will have to get refactored to inherit this class in order for this to be valid. So I will not do that in this lesson. I will not do this refactoring here, but just keep that in mind. The final bot implementation will have all that cleaned up and everything reorganized. So what we're going to do here is we're going to add an elif here. So if the order type is, let's see, let me just copy this. What are we looking for? We're looking for a buy the dip strategy now. We're also going to check to see if the order is an instance of strategy order. That's just a robustness check. You don't have to do that, but it's more of a robustness thing just to make sure that the entries are good. We're going to go ahead and return a strategy order, or I'm sorry, we're going to actually create the strategy. We're just going to call this something very generic right now. Strategy 1. All right. Name it whatever you want, but that's what I'm naming it right now. And what are we going to need? We're going to need the same information that we passed to the P&L trading engine, right? It's the same data. We're going to pass in our token info. We're going to pass in an order executor, which is this class basically that will allow us to execute the orders. And we'll also pass in the order itself that has information on how to, has the configuration for the strategy basically, right? So we haven't created this yet. We will. So I'm getting some errors on this. Let's go ahead and implement our abstract trading strategy. And let me go ahead and actually do the imports already from Abstract Trading Manager, import everything. And we're also going to import from strategy 1, we're going to import strategy 1. Okay. So let's create a new class called AbstractTradingStrategy.py. And basically what this is going to be is, what I did is I took the guts out of this P&L trading engine. So a lot of this could be reused in the P&L trading engine that we implemented in the last module. So what I did is I took a lot of this stuff and I abstracted it out because it's reusable code, right? So I'm just going to cut and paste what I did, and I'll just go through it with you really quick. So, but yeah, it's nothing new. Basically, I have a constructor here, and I have, this is obviously a thread, inheriting from thread. And I have I need the token info, I need the order executor, I need this, I need to keep track of state of the strategy. There's a locking mechanism to lock up critical sections. And then there's an unprocessed event counter, which I explained in the last module how I use that. When you run this thing, when you run this thread, it'll go ahead and subscribe to the token update event. So that is one topic that we need to get the current price, or to get price updates for a particular token. The stop is the ability to unsubscribe to that update. So once this thing finishes, we don't need to subscribe to the updates. This thing should go away. We have an internal method called process event tasks that will go ahead and do the processing on this event, and it's going to call an abstract method called process event. So that's why I call this an abstract class. It's because the inheritors of this class will have to implement this method. So this class has no knowledge of process event. All it is an abstract method. There is an abstract method that defines this. So this is a placeholder basically so that implementers can implement this. So this is the beauty of abstraction. You can abstract away the common code and you can have the implementers implement that. So this increases the maintainability of the code and creates smaller code chunks to work with. So it just makes things a lot easier for maintainability and optimization. The other thing we might need is the order type. Right now, I just threw this in there. We may or may not need this, but just threw it in there to get the order type of this particular strategy. That's it. So just a quick update if you weren't following in module 4. So when this thing gets an update, it'll go ahead and check to see if this is a token address for. So it doesn't hold up the caller. It'll go ahead and set up a timer to go ahead and run. Processing this event could take some time depending on what it has to do. So it's going to go ahead and check to see if there's any events that were missed and go and reprocess those things as needed. So that's what this is checking. If this is not complete and if the unprocessed event counter is hit, go ahead and recursively run this again. So basically that's what that is. Same code as last time. It was in PNL trading engine. I just abstracted that out. So we got this. So our problems in Trading Manager for that go away. The next thing we got to implement is trading strategy, or I'm sorry, strategy 1. So let's go ahead and implement strategy1.py, calling it strategy1.py. All right, so this is the meat and potatoes of what we're trying to do here. So first things first, let me go ahead and just cut and paste. Obviously we have to create a class, right? And we're going to, let me just cut and paste what I got here, make things go a little quicker. So the first thing we got to do is we got to instantiate this class, and then we're indicating that this is inheriting from Abstract Trading Strategy. And I got my constructor here, and I'm doing the constructor initialization. Here we need to set up our order settings, and then we need to also set up a signal generator. We'll get to that part in a second. We don't have this class yet. Then we got our P&L options. That's basically our limits and stop losses. So if you remember from the past modules when we set up our limit order, then basically just the same thing that we implemented last time in our P&L engine. And then we're gonna have a function called load from dictionary. So we're gonna load this strategy up given the strategy settings that we're given as an input. So let's start implementing the rest of this class. So as far as, remember, we're inheriting from abstract trading strategy. Well, we got to create the functions that are abstract. So one of them was get type. What type of order this is? Well, this order type is a simple buy dip strategy. Simple. The next thing we got to do is we got to implement the process event, and Visual Studio Code took the liberty of trying to define this for me. That's not the implementation I want. So what we want to do here is we want to, this is going to be very simple, really. So what we want is we want to get the trigger state off of our signal generator. So if self.TokenDipSignalGenerator, we're going to go ahead and update it, our signal generator. We're going to have, this signal generator is not going to run on its own. It's going to go ahead and, we're going to go ahead and update it and see what the trigger state is based on that. So the idea here is if our price dips below a certain amount based on our settings, this signal generator should tell us that. It should give us a state, whether it was triggered or not. It's as simple as that, untriggered or triggered. Those are the two states. We do need to implement those states. We'll do that. All right, so the next check here is we're going to check on the triggered state. So if we are triggered, we're going to say that this strategy is complete. So fulfilled our mission. There's some steps we need to take in order to fulfill this mission. We need to actually place a buy order, right? So that's where all this comes into play. I'm just kind of pasting this from passcode because I don't want to type this all in. The order executor. We've done this before, module 4. Okay, so next we're going to check to see if we actually do have a signature. So that would mean that our buy order went through. If we don't, we probably want to notify the user that this did not occur so that they can take some action. So I will not do that in this lesson, but that's just something to consider. So I'm just kind of pasting this from passcode. So we'll go ahead and get the transaction info off the chain here using the order executor to help us. And let's see, based on this, what we're going to try to extract is the swap info. Basically, we're going to try to figure out what the token amount is that we actually bought. Because of slippage and all that, we don't know that right off, so we do need the transaction to get that. This is the same code I had in the main.py before in module 4, so I'm just cutting and pasting from that, redo all that. So I'm going to calculate that. We could create a little utility function for this. The final code, I will reorganize this. Like I said, it'll be a little bit cleaner. Things that we can reuse will be packaged up very nicely in utilities class. But anyway, I'm just calculating the swap info here, number of tokens we bought, our base token price, so that we can create a limit order off this. So I don't want to just buy this thing and hang on to it. I want to create a limit order so that I don't have to be at my keyboard. So when this thing buys, and I want to go ahead and sell it for a profit, or cut my losses if it gets to that point. So once I have all that calculated, I'll go ahead and create my sell order, and I'll create a limit order off this basically. Notice how I'm chaining things together. So I have all these reusable components in my software now that I can use. I don't have to recreate this limit order stuff code. Basically, I'm just creating the limit order. So in addition to that, I'm going to go ahead and add in the limit orders to this order. So remember up here, I'm gonna have an array of P&L options. This is basically, I'm gonna have one for the limit order, I'm gonna have one for the stop loss. So that's all I'm doing here is I'm cycling through that array and adding those options in there if they were configured. Next thing I'm going to do is I'm going to go ahead and execute the order, and you can actually check the signature on that if you like, but robustness, you probably should check it and alert the user that it did not go through. That's it for this. On the else, let me go ahead and just do a little printout issue with executing the trade, and I add a little to do here. Future feature, notify the user. Typically when you're doing software development, you want to add in to-dos. So if you got an intention to do something later, just add these in. If you're working with a team, that could be something they do, you task someone to do. A lot of times they will just stay there forever. Nobody will work on them. But anyway, it's one way to not forget about something. All right, so the last thing we want to do is we want to do a stop on this. So if we actually got to this point, and that means we're done, we don't need to continually listen for token updates. So we're going to go ahead and just call stop there on this strategy. All right, so there's a couple things we need to do here to make this work. We need to implement our token dip generator. We also need a signal state. We don't have that. So let's just implement our token signal generator. So I'm going to call this token TradesManager.py, and I'm just going to paste the few things here. All right, so in our token dip signal generator, we're going to have a constructor where we have our token info. We're going to pass in the market manager so we can get price updates, pass in our chart interval. So that would be the length of the candles, the time length of the candles. Do we want 1 minute charts? Do we want 1 second charts, etc.? That's what that provides. And our trigger drop percent. So from candle to candle, what drop are we looking for in this generator? Our trigger drop percent is going to be, well, we're converting that to 2 UI value. So that's going to be a real percentage. So if it's 50%, we're going to go and divide that by 100 to get the decimal percentage. It's just easier to work with when we're doing comparisons here for price fluctuations. So this is going to be really simple, really, guys. It's going to have one method, and what it's going to provide the caller is the signal state. whether this condition, the condition for this generator, is triggered or not. So we're going to assume that we'll just initialize our signal state as untriggered. And what we're going to do is we're going to get the latest candlesticks. We will create this in a second. So this will probably be the hardest part to understand, but I'm sure all of you are familiar with looking at a deck screener chart or BullX chart. You guys understand what candlesticks are. So this is the first incorporation of those into our strategies. I doubt that any premium bots have this right now feature. After watching this, they probably will think about it, but I don't know. Let me know if you know of any bots that can do this as of right now. I don't even think BullX will let you do this. And this is a very basic strategy, by the way. All right, so we're gonna get our market manager, and we're gonna go in and we're gonna have a function that we're gonna create in our market manager called get candlesticks. So why are we giving this responsibility to market manager? Well, the whole idea behind market manager is it's supposed to maintain all the information for tokens that we're monitoring. So it's supposed to maintain all the information that we need to make informed decisions. So you can kind of look at this as sort of your behind the scenes work that your deck screener is doing, that your BullX is doing to show you the data on the screen. So basically that's our market manager. It's basically monitoring our tokens for changes and allowing us to query for that data. So it's got a pretty specific responsibility there, right? So let's go ahead and to get our candlesticks, we're gonna need to pass in our token address. We're gonna pass in token address, and then the other thing we're gonna pass in is our chart interval in seconds that we're looking for. So we're gonna have to set up the manager to actually maintain this information, but we'll do that. So if our latest candles, if we got latest candles, we're gonna check to see, because there's a chance that we might be asking for something that doesn't exist. So typically when you go on a deck screener view, there's a limited number of options. Choose from 1 second, 5 seconds, 1 minute, etc. It's limited. It doesn't let you customize it. This will actually be very customized. You could actually choose whatever interval you want potentially with this code. But I'm just going to use the standard. I'm just going to implement the standard ones for now, or configure the standard ones. So right now I'll just focus on 1 second and 1 minute candles right now, but this will be very easy to configure in later iterations of this. All right, so we'll check to see that, and then we'll get the length of the latest candles. Make sure we actually have 2 candles to work with. So that would be your current candle. So that might be a not completed candle yet. And then the last one. So that's what we're comparing to, the closing price of the last candle. So let's go ahead and just, once we meet that condition, we're gonna get into this block, and then we're gonna get the length of the candles. So this could be, say you're running this for a while, you might have a lot of candles in there. So we just want to get the length of that. The reason for this is we want to get the last 2. So we want to get the previous close price and the latest close price. So latest candles will just be an array of each candle, and each candle will have a variable called open, close, volume. There's other ones in there. It's just the standard. Those are just standard attributes for candlesticks in general. So I try to implement those here. So what we're going to do is we're going to get the close price. And you might not agree with this right now. This is just the basic algorithm, basic strategy. So just to give you an idea on how to do this, you can tweak this however you need to. But we're going to get the previous close price of the last candle, and then in our current candle that we're currently working on, we'll get basically the last price. And what we're looking for is a drop. So if our latest close price is less than our previous close price for our previous candle, we're going to go in and calculate the percentage change. That means we dropped in price. That means we're losing. That token is losing, right? A little bit. So we're going to do a 1 minus the latest closing price. Got to do some basic math here to calculate our drop in price. That should give you the drop in price percentage in decimal. If this percent change is greater than or equal to our drop percentage that we're looking for, so that, remember in our constructor we initialize this. So if it's greater than, that means we've triggered. And our signal state, we're going to go ahead and set that to signal state. Kind of hard since this thing hasn't been created yet. Still in this soft memory. All right, so we're gonna set this to triggered, and why not go ahead and print out a little something too, just for debugging. Trigger for trigger drop percent occurred, percent drop is, and we're gonna multiply this by 100 to get the real percentage. That's it, nothing fancy there. And lastly, what we need to do is we need to go ahead and return our signal state. All right, so now we're done with this class, but there's one little change we need to make here. So in this scenario, I'm testing to see if latest close price is less than the previous close price. What I really want to do here to make things a little more interesting is to check the lowest price of the previous candle. So what I'm going to do is I'm going to change the name of this to previous low price. And what I want to do is I want to get the low price of the candle. So this is the lowest price in that previous candle. So that's it. That's the only change I need to make here. So when I'm doing the test here, this check here, I'm just checking to see if the latest close price or latest price is less than the previous low price in the previous candle. So that's it, we're done. Next, we need to implement this, the signal state, and we're going to implement this in TradingDTOs. Very simple, it's just an enumeration. So doesn't matter where you put it. I'll put it under strategy state. So signal state is triggered or untriggered. That's it. All right, so let's go back to our signal generator. So one thing we don't have is the get candlesticks method. So we're gonna have to go to the abstract market manager, and that's in TradingDTOs right now. Right now we only have one abstract method defined, so we're gonna create one for market manager. Very simple, just another method called get candlesticks. Boom. It's going to take in a token address, the interval that you want, whether it be a 60-second interval, which would be a 1-minute candlestick, and it's going to provide you a list of candlesticks if they exist. That's it. So we need to go, now that we've done this, we need to go in our market manager and implement that. So market manager is already implementing abstract market manager, so we need to just make sure that we implement that in our market manager. It's not too difficult. So let me go ahead and cut and paste the signature for that here. Let me see, where's a good place to put this? Candlesticks. Okay. All right. So what are we going to do? Well, we're going to maintain something called candlestick builders in this class, and we'll get to that part. But what we're going to do is simply put, we're going to return candlestick builders will be a dictionary for each token. We're going to incorporate token address in here. We're going to get the right candlestick builder for our token if it exists. And we're going to call something called get candlestick builder. Hang on, I'm going to rename this really quick. I don't like this name. I'm just going to call this candlesticks. So this is going to be a dictionary that represents the candlesticks for each token. So we're going to maintain the candlesticks here, and if it does exist, we're going to call something called get candlestick builders or builder. Here we're going to go ahead and pass in the interval that we're looking for, and we're going to get all. All right, that's all we got to do there. We're going to get all the candlesticks for that token that we have available. And you might think, oh, by the way, what if this thing is running for days? We're going to run out of memory. You know, you might have a million candles built up, you know, by the time you run it. Well, there's a protection against that, and we'll get into that. There's a limited size for this, for our use case. If you need more history than just, you know, 24 hours, then you'll probably have to seek other methods to store that candlestick data or retrieve that candlestick data from some other source. And we'll get into that in the advanced material. But anyway, I don't want to divert too much on this, but when we get into the candlestick implementation, I'll explain a little bit more about that. All right, so let's go ahead and initialize our candlesticks in the constructor here. So something new here in our market manager, we'll go ahead and just put this at the end here. So we want to ensure that we support 1-minute candlesticks, 1 second, and 1 second candlesticks. You can adjust this as required. For example, if you wanted 5-minute charts, you just put in 60 times 5. Just makes it more readable that way. So if you wanted 5 minutes. So right now I'm only supporting 2 types of candlesticks. All right, so now I'm creating a dictionary for each token, or that will represent each token that we want to monitor, right? And up here, up top here, I'm going to go ahead and do the imports from candlesticks. We're going to import something called candlesticks. And in addition to that, we're going to also import, we're going to need something to time each candlestick. So we're gonna have something like that for that from daytime. That's a standard library for Python. All right, so one last thing we got to do here. Let me go to just while I'm here, might as well do this. So when we monitor a token, we want to go in and check to see if we have candlesticks initialized for this token. So we're going to go ahead and do it if token address not in self.candlesticks. We're going to go ahead and initialize that dictionary entry, right? So in our monitor token. So that when the user calls this or something calls this, we're assuming that this needs to be monitored, that we need to maintain candlesticks for this particular token. So we're going to go ahead and initialize our candlesticks, and we're going to go ahead and set our default intervals based on what we set in our constructor. So that's that. That's all we got to do. That's the only change we got to make. We need to implement our candlesticks implementation. So we're going to create a new class, new file called candlesticks. First off, we're going to implement the candlestick. It's just going to be a simple data structure, and it's going to contain information that you find in any piece of trading software for candlesticks. So what we're going to have here is we're going to have a start time, which is initialized in the constructor. We're going to have our intervals, the intervals that this candlestick represents. So this could only represent one interval. So it could be a 1 second interval. It could be a 60-second, 1 minute interval. So, and then the open price. And yeah, we're going to track the open, the high, the low, and the close, and also volume. This is just here the placeholder for now. We're not going to track the actual volume just yet. So that would be the amounts that are being transacted through these candlesticks. That's going to be very, very useful for certain trading strategies to have that info. But for now, we'll just keep this very simple right now. But I'll just leave that in there for the future. So the next thing we want is we want a way to update our price. So this candlestick, we're going to have some logic to update the price. So there's some conditions that need to be met to change certain values. So if this price is above our high price, then obviously we're going to set our high price to this current price. If the price is below our low value, our low price, we're going to set the low value to this price because it reached bottom. Now you might be asking, why are we using the amounts class for this? You can represent any type of value you want with the amounts class. Well, there might be a lot of candles in here. I don't want any performance hits because of that. So there could be thousands and thousands of candles that you're collecting. There's a little bit of overhead in instantiating classes objects. So if you're doing that a lot, you want to limit your class instantiation. So hopefully that makes sense. So we're just keeping the raw value of price in here. We're just assuming this price is likely in the currency that we're dealing with, which is Sol. All right, so the other thing is we want to just initialize close price to the price, because it's the close price would be the last price you got, and then the volume will just increment by 1. So this will kind of just tell you, okay, we had a change in price and it occurred, and we're tracking the occurrence of it. This might be equivalent to the makers attribute that you've seen on Dex Screener, so it could be useful information. Later on, we'll track the actual movement of, we'll actually calculate the actual amount of volume that is actually moved in USD in the future. All right, the next thing we want to do, let's see. Yeah, we're done building this. So the next thing we want is we want something to be able to build our candlesticks. So this will be a little bit of a helper class, but I'm just starting it in here. So we'll need a class called Candlestick Builder. But let me change the name. There's no uppercase on candlestick. I'll just change that. Okay, going down here, Candlestick Builder. What we want to do is we want to just initialize a few variables here. So we're going to track our interval, our current candlestick. So let me just rename this. We're going to track our current candle, and then we're going to have a list of candlesticks, right? So in addition to that, we're going to have a max length on this candlestick. So we don't want this thing to grow too far. So we could probably limit it safely to 24 hours per token, and we'd probably be okay with most systems currently. But keep that in mind. There are going to be limitations to this. You will likely, if you need more history data, if you want to track more history data, you'll have to use a database, and we can get into that in the advanced material. But just for now, just know that we're going to limit this to 1,000 samples, basically 1,000 candles. So if you have 1 second intervals, then that means 1000 seconds. If you're working with 1 minute intervals, then you're gonna have 1000 minutes of candles, so etc. So the next thing you want to do is you want to go ahead and you want to create something called update, and we're gonna be part of this class. So and solve. We're gonna need a timestamp on the data. So it's incumbent on the caller to give a proper time, and we're gonna put in the price, and we're gonna assume that this is a floating point value, decimal value. And we're gonna add in a condition in here. So this will basically check to see if there is a current candle initialized, or if the time has exceeded the current candle, which would mean that we need to close out the current candle and then create a new one. So we're going to go ahead and set the current candle. If this case is met, we're going to go ahead and set this current candle to candlestick. We'll just go ahead and pass in some variables here. So we're going to pass in the start time. Sometimes I think you've probably noticed this, but sometimes I like to indicate the variable name here, just so it's more clear as to what I'm passing into these inputs. That's optional. I could just do this, but just FYI, in case you're wondering. So it just sort of makes things a little more clear, but you don't have to. So one caveat is that these initializations have to, they don't have to be in order, as long as these names match up. But any variable names that you don't specify, like for example, if I just pass in the timestamp, the order does matter. It has to adhere to the same order as the signature that's defined in your constructor or method signature. So just FYI, so I couldn't just do this, like this would cause an error. Oops. Yeah, I couldn't just do that. It wouldn't understand where this belongs. So just FYI. So that is one of the benefits to naming things, or specifying the variable names there. All right, so what we're gonna do is we're gonna take our current candle, we're gonna go and append it to our candlesticks array or list. And the next thing we're gonna do is we're gonna check to see if our candlesticks length has exceeded our max amount. So if it has exceeded our max length, we're going to go to pop off the first element. So that would be our oldest element that we're going to pop off. And once we do that, we're going to take our current candle. So we want to set our current candle no matter what happens. This is just right here. This block right here is just robust. Just checking to see if we need to make a new candle, and also checking if we need to limit the size of our list. So we want to update the price of our candle. So it's going to call update, and we'll just update the price. All right, the next thing we need here is we need a get all method. So we were calling that before. So we're going to do a get all and then pass back the candlesticks. It's just an accessor method. And the other thing we'll go ahead and implement is a get. So say we don't want all candles. So this is just something for the future. Say we just want a limited amount. Say we want the last two or something like that. We just pass in 2 as count, and that's what this would do. So first things first, we make sure that candlesticks is big enough to give you the caller what they want. And we're going to go ahead and return that amount. So you just put in a negative count in this syntax right here, and that'll give you the number of elements at the end that you want. All right, last thing, we need a class called Candlestick. So this is the one that MarketManager will be using. This kind of ties everything together. So this is probably what the callers will be using. So what we need is a constructor for these candlesticks, and we're going to maintain a few things in here. We're going to maintain the candlestick builders. So we're going to have candlestick builders per interval. So we want to maintain a builder for each candlestick length, right? So we're going to have a dictionary for that. And for each interval, we're going to go ahead and initialize the candlestick builder for that. So we have 1 second interval, we're going to have one candlestick builder for that. For a 60-second interval, we're going to have another candlestick builder for that, etc. That's it. We do need a way to update. So what would happen is we'd have an update method, and this would be a wrapper kind of around the candlestick builder update method. So we're going to create this for loop that iterates on each candlestick builder. So we're going to grab the candlestick builder. Let me change the name of that. So for every candlestick builder in our builders dictionary, we're going to go ahead and call update. We're going to pass in the timestamp given, and we're going to pass in the price, so that should update each candlestick properly. Big builder, so if the caller wants these 1 minute interval candlestick builder, then they should be able to get that. So if that exists in our candlestick builders, then let's go ahead and just return those candlestick builders. And that's it. we're done here. So let's go back to Market Manager. I think we need to make one correction here. That change the name of that candlestick. We're gonna have to import candlestick. We could just do an import all on this. Do that. That gets rid of all the squiggly lines. I think we're good here. Let's check strategy out. TokenDipSignalGenerator. We need to import our TokenDipSignalGenerator. Get rid of that. Should be good. Let's check out our trades manager, see if we're missing anything. No, we're okay. To get rid of that squiggly line there, because that's what we're producing. List of candlesticks. And that is it, I think. I think we're good. All these classes are green. We do have a red mark somewhere. I don't need this thing. And just for, I don't like having this up here. I'll just have this up, this subscription thing at the bottom here. Right, stuff out. So we got to create a little mock test here. This stuff is super hard to test in real time. Certain market conditions have to be met in order to execute some of our code. So in order to get a dip, we would have to experience that in real time. So we need to create a mock test for this so that we can force those conditions and test our path of execution and our code. So let's go ahead and do that. So building on what we did last time, remember we had we tested our P&L trading engine that way. So we're going to do the same thing, but we're going to go ahead and test our strategy one. How do we do that? Well, it's the same thing. So first off, what I want to do is I want to modify the market manager. Right now, it's just supporting one price for a token, and that's okay. We'll keep it that way. But we want to add in candlesticks in here. So let me go ahead and add in some more imports here that we need. But this market manager has to maintain candlesticks now, right? So we'll do that. And the next thing we want to do is we need a method called get candlesticks. You could easily just utilize the market manager that we have already, but you have to load that in with the RPC node. And let's see, what would you need to initialize this? You need an RPC. You have to initialize your RPC node and all that. I don't really want to do that, so that's why I'm creating this mock market manager here. It's simple enough to do, so it's just a mock class. All right, so we got our candlestick here. All right, so we have a method for getting the candlesticks, and it's basically a cut and paste of what was in the market manager. In addition to that, we're gonna have an update price method as well. This is just something that for us, right? So we can manipulate the price as we want it. I'm creating that, and what'll happen is we'll just update the price of our current token. And this is just a one-on-one. We're not trying to mimic any other tokens. We're just mimicking a fake token here. So when you do this get candlesticks and passing the token out, that doesn't mean anything here. This mock manager just representing one token, fake token. And that's enough for this mock test. So what we're going to do is when we update the price, we're going to go ahead and update our candlesticks with the new price. And we're going to pass in our current time, right? So we initialize current time to the current time now. And when we update the price the next time, we want to update the time by 1 second. So that would mean that we have the highest resolution for our candlesticks is 1 second. So we're going to update the time by 1 second. So on the next iteration, we'll go ahead and be 1 second past, and we'll go ahead and initialize the next candle, 1 second candle. So that's the idea here. This is just fake that behavior. And you'll see it'll make sense in a second why we're doing this, because we need to preload this with existing candles so we can actually test this. The next thing I want to do is I want to clean this up, because I put all this stuff in P&L, the test for P&L trading engine, but it's stuff that I can reuse. And I don't want to copy paste all this stuff into another method. What I want to do is I want to encapsulate all this information into one class. So I'm going to call this class test setup. And this is just for this mock test thing. So what we're going to have here is I'm going to initialize market manager, mock market manager. I'm going to initialize, I don't need this. I'm going to simulate 2 minutes of data. So I'm loading the market manager with new prices and basically just creating randomized prices from 100 to 200. It doesn't matter what the values are here. I just want to mimic some token value changes. And then I'm going to initialize the token info and then initialize the decimal scales to 1 to the 9th. And all the other stuff, the buy amount, initial buy amount, slippage, priority fee, all that jazz is in there. And also the P&L options as well. And lastly, what I want to do is I want to set up the executor the order executor. So I'll set that up as well. And a lot of this code can go away in the P&L trading engine. So I'll just refactor that really quickly just to clean it up a little bit. So let me just clean that up. So just cut and pasting that. All right, so now we're utilizing our test setup. It's a good idea to keep your old test cases in here. So you typically, when you change your code, you want to rerun your old test cases just to make sure they pass as well. So that's why I'm maintaining this. So I could have just left it alone, but new changes can impact your old code as well. So that's why this is important. So, all right, so let's go ahead and create something for testing our strategy one. So we're going to create something called test strategy one. We're going to do the same thing here. We're going to create a test setup. Strategy settings. We have a couple options. We could load our strategies that are in here from the file, or we could just create the string on the fly. And I'm going to choose the latter here. So I'm going to create this thing called strategy settings here. All right, so it's basically a cut and paste of what I had in the JSON file, but it allows me to kind of mess with it without changing the apps, the final apps configuration. All right, so next I'm going to get the token address from test setup just for convenience. And what I'm going to do is I'm going to create a strategy order. So this is kind of the same code we had in the main, right? I'm going to create a strategy order, pass in the simple buy the dip strategy enumeration in there, and then pass in their strategy settings. And this could be the first part of your test. You know, you could debug this, walk through this, make sure that your strategy order is getting implemented correctly, make sure your strategy, we're going to create the engine here, we're going to instantiate our strategy one. So that would be the first place to start testing, just make sure that stuff works. And so we have some candles in there already from our test setup. So what we're going to do now, after starting our engine, we're going to force a 10% jump in price. Oh, by the way, I set the chart interval to 1, so that means that we're using the 1 second chart. So if the price jumps, if it goes down 2% from the last second candle, then that means that we will go ahead and execute a trade. That is a strategy, right? So we're going to jump it 10% up. So that's where this comes into place, getting the current price and then multiplying it by 1.1. That would be a 10% increase in price. And we're going to force the handling of the update, just like we did with our P&L engine. So this thing, just a reminder, this handle update thing is an event-driven thing. So this will be called by the event or the publish mechanism that we have in place. So if there is a price update and we are subscribing to those token updates, this will be called automatically. But we're kind of forcing its hand here. We're forcing the price update. I don't want to utilize the pub and sub. We know that works already. I just need to make sure that this, when I call this handle update, it's doing the right thing. So that's all I'm doing here. So this is an asynchronous call. What it's going to do, it's going to queue that basically to get handled. So I need to sleep for a second just to give it some time to do that. Should happen pretty much instantaneously, but I'm just going to do that I'm going to do that sleep there just in case it doesn't finish in time. What I'm going to check now is I'm going to put in assert. This is my test case, my first test case. So price jumped up 10%. The strategy state should still be pending because we did not hit our mark there. It went up, not down, right? We want to buy the dip. So we know that it went up. We got a candle. We have a new second candle in there. Let's force a 2% drop now. An exact 2% drop would be 0.98 of the current price, 98%. So let's go ahead and handle that update. Same thing. And what we should get here afterward, we'll go ahead and sleep 1 second, and then afterward we should get a complete state. So if this is not assert correct, that means our code isn't working, right? Because we forced the hand. We forced the 2% drop price, and it should be complete now. So going back to strategy one, just to remind you what happens once we're complete. So it'll check with the token dip signal generator on whether it triggered or not. So that would mean we got the 2% drop. And if it is triggered, then we'll go ahead and set that state to complete. Then it'll try to execute the buy order, right? And then after that, it'll set up a limit order so we can sell it automatically. So we will not test the limit order part because we know that works already. That was tested in the past. So as long as our limit order test case still works, we should be good to go there. So we did not need to retest that. One good idea for new code is going back to bots test is go ahead and set up. I think I've shown you this in the past. Go ahead and just walk through the code slowly, just throughout the new code, just to make sure things are getting initialized and working out the way you think they should. So you'll catch a lot of bugs early on that way if you just walk through it the first time. So that's it. So let's go ahead and test this out. And after I do that, I will go ahead and do an actual real live test on a token. I may have to let it sit for a while to show you guys how it works, but I would definitely will show you a real world example. All right, so testing. All right, so I already found a little bug here. There's a problem here with my naming. So let's go to, let me just match, this name doesn't match the variable name. Let me just change that really quick to allocation percent. So I just needed to correct that. Let me go to retest. All right, so one thing I missed here, we have to implement, going back into strategy one, let's implement our load from Dict. We need to load our settings from our strategy JSON, and it's already in should already be in dictionary form here when we pass it in. And we did call this at some point. So this is called in the constructor. So we're passing in our strategy settings in there. So this need to be done, otherwise this will not work. We're gonna parse out our sold buy amount, our slippage, priority fee if it's there, limit orders, stop loss orders, and if this stuff is not in there, then it's not gonna set it. So we'll just use the defaults in that case, but that's what we're checking here. We'll go ahead and set those settings if they're there. If not, it's okay too. We still have our default settings. And also for the limit orders, we're gonna go ahead and append each P&L option to a P&L options list. It doesn't matter if it's stop loss or limit order. P&L options are apply to both basically. So, and then we're gonna track our trigger drop percent. We're gonna read that out of there, our chart interval, and we're going to create our token dip signal generator based on some of that information. So our token info, we're going to need to pass it our market manager, our chart interval, and then trigger drop percentage. So that concludes that loading from dictionary. One more thing, I made a little error here. I'm updating the current price. Let me go to rename this price. All right, so after making those corrections, I'm just rerunning my previous test just to make sure everything is okay. Test P&L trading engine is running fine. So I set my limit order and the limit order was triggered after I forced it. Also tried the stop loss order and that was triggered as well. So things are good. So tested that. Like I said before, it's always a good rule of thumb to retest your previous test cases if you made changes to your code. All right, so now we're going to test our strategy one. Let's go ahead and do that. And there's a more robust way to do this. This is just, I'm just throwing this together for this course. So, but I can cover more advanced testing methods in the advanced material. So let's just go to test strategy one, and instead of calling handle update, let me just do the same thing because I don't want to run into that same issue where I have to wait for the thread to finish. Don't need to do that, right? So I'm just going to walk through this and make sure things are working properly. So let me go and run the debugger. So strategy settings is set, and we're going to go ahead and initialize our strategy order. We got that. Okay. We're going to go and initialize our strategy, and then we already got an error on that. And the problem is we can go to the line on strategy.py. I am calling P&L option from dictionary, and that does not exist. So let's go ahead and implement that. I forgot about that. So basically it's trying to initialize a P&L option. So if you go back to our JSON string, so this is JSON, right? So it's trying to take this and it's trying to convert this to a P&L option object. And we don't have the necessary function for doing that. So let's go back into our TradingDTOs. Search for P&L option. By the way, you can go up here on Visual Studio Code on this bar here, search bar, put in an @ symbol and type in what you're looking for, P&L option, and it takes you right there. This is simple, really. So all we need is a converter. So we're going to create a method here. It's just going to be a static method, and it's going to be called from_dict, and we're going to take in our dictionary, and we're going to initialize these amounts. We're going to create these amount objects using the amount method %UI, and we're going to pull out our trigger at % from our JSON, and then we're going to do the same thing for our allocation. So hopefully that makes sense. We're just creating objects out of the JSON, basically out of this, and that's it. That should resolve that issue. So let's go back in our bot test and retest. Okay, see that initialized, and okay, it looks like our engine initialized okay. So we should be all right. and we're going to go to start, and we're going to go ahead and fake a 10% jump in price. So what is our current price? It's 189. We're going to fake that. What is our current price now? It's 207. We're going to go ahead and process that event task, and we should not hit any sort of trigger. And we're going to assert the state is still pending. It is. Now we're going to force a 2% drop. This should trigger our state, right? So we're going to update the price, and our current price is 207. That would be our last candle, right? And we're going to create a new candle by updating the price. What is our current price now? 203. So we force that price difference, and it did trigger. See, no, I did have a printout for it. So it said, hey, I triggered. I dropped 2%. And what is the state now? It's complete. So we know that this code works. You could test other cases, like if you wanted to try a 5% drop or whatever, it doesn't matter. I can do that right now for you if you want to see that. So let's say we want a 5% drop, want to test that out. You can either add another test case for that. It's good to randomize your tests a little bit just to make sure all your paths are covered. But typically I'll do edge cases. So if I set it for 2%, I'll test that case, and I'll just do some randomized tests just to make sure that it's good. So let me go ahead and test this. It's a 5% drop in price. It should still trigger, and yeah, it did. So see that percent drop, 5% exactly, right? So it looks like this code is working right. So we should be able to go ahead and execute our main. And this one I'll have to leave running for a while, and I'll have to get back to you guys on this one. I'll go ahead and post the results on the official Crypto Meta Twitter page or X page. Please subscribe if you haven't already. It'll really help the channel out. There's a lot more going on with this one. So not only do I have to buy on the dip, I also have to execute a limit order. So we know that the limit order stuff works, so I have confidence in that. So really what I need to do is just test the real-time ability of this thing to buy a token, and just check to see what the limit order was set at, and then just monitor it for however long it takes to go ahead and sell for profit or sell at a stop loss. So that pretty much concludes the module. Thank you for joining. I will see you on the next one.